Hi everyone. Today we are going to learn how to use Python in order to backtest a simple moving average strategy. We will show the Python code to run the backtest, the returns that we got from our backtest, and also, as usual, there will be the download link to the notebook in the description below. Please like and subscribe if you like to see more Python backtests of trading strategies like this one. So we will go through the rules of the strategy. We will show some examples of the strategy, such as this one here, and we will go through all of the Python code required for backtesting the strategy. Finally, at the end of the video, I will discuss some important pitfalls where the strategy does not work, so that you can sort of avoid those pitfalls when you trade the strategy. So what is the strategy? As you can see here, we have the data from 5-minute data for Bitcoin here, and we have plotted two moving averages. One is the 20-day moving average, which is sort of the more jagged line here, and one is the more smoothed line, which is the 100-day moving average. So there is a slow moving average and a fast moving average. And we take a trade when there is a crossover and the fast moving average crosses the slow moving average. This is the entry point of our strategy. The reason that we take the trade when the fast moving average is larger than the slow moving average or crosses over the slow moving average is because this indicates that there is an uptrend in the stock, as you can see here. However, as you can also see, this is a lagging indicator, which means that by the time the moving average crosses, we are already somewhere here. So let's go through the formal rules of this trade. So as we discussed, the first rule of this trade is that the entry is when the fast SMA crosses the slow SMA here. And the exit is where we put equidistant profit, take profit, and stop loss, and this is our exit criteria. It may not be, the take profit and stop loss need not be equidistant, but in this case, that is what we consider. Going back to our example here, we will enter the trade somewhere in this region where the fast moving average crosses the slow moving average, and we will enter at the next candle, which is an important nuance that I'm going to explain right after this. But when I place this trade, what I'm going to try to do is to put a take profit somewhere here and then a stop loss somewhere here. The price can do one of the two things. It can either go above the take profit area, in which case we take profit, or it can also sort of touch the stop loss before we get to our final profit. So let's look at the example of what this trade did. So here is what this trade looks like. And as you can see here, we entered on this candle here. And then, and then we were able to exit at this candle here at a take profit. And we never hit the stop loss. So now let me explain an important nuanced point but that a lot of backtesting videos miss about the crossover of the SMA. We have to take the trade at the open of the candle right after the crossover happens. So in this case, the crossover happens in this candle here, but before this candle closes, we do not know whether the crossover has happened in real time. So this means that only at the open of this particular candle, we know that the crossover has happened, and this is where we finally take the trade. This is an important nuanced point that can cause changes in the amount of profit that you have from this strategy. So that is something important to remember. So now that we have gone through an example of the strategy and the rules of the strategy, let's see how to code this up in Python. Let's go to the beginning of our file, and as always, we download some data, which again I will link in the description below, where we have 5-minute data for Bitcoin to USD, and this is, as you can see, like a 5-minute interval time frame. And then we plot this data, which is too many candles, but we plot a small sort of subset of the data. And we also add the 20 and the 100-day moving averages. So we take this data, we take a small subset of the data and copy of that data frame. And then we take the mid of the data frame. The mid is the average of the open and the close. And we decide to calculate the rolling average of the mid point of the candles. You can also do it for the close, which would be a slightly different version of the strategy. So we calculate the fast moving average by looking at the 20-day moving average, the slow moving average by looking at the 100-day moving average, but the rolling function basically allows us to consider sort of the last 100 or 20 points, and then the mean basically says take the average of these points. And then finally we look at the difference between the fast and the slow moving average. And then we calculate the crossover. And we look at, so the shift basically considers what happened 2 candles before. So 2 candles before, the difference was less than 0, and the candle right before, the difference was greater than 0. So that is the crossover. If we go back to the visualization before, we want to look at the case where 2 candles before, the one we don't show here, this is when the slow moving average was larger than the fast moving average, and the candle right before, 1 candle before, the fast moving average sort of crossed the slow moving average. This is what we see in the code here. And these points are sort of the crossover points, which will be 1 when the crossover happens or 0 otherwise. And here we sort of plot the example which we showed here. And then finally we come to the strategy. In the strategy, we have some parameters here. One is the proportion of time we want to buy, which is sort of a random, if we want to sort of buy randomly, sometimes when this crossover happens, we can set this to a number less than 1. If we set it to 1, we basically buy whenever a crossover happens. And then the max buy says how many we are allowed to hold at a particular time, because we have only limited funds. And the profit and the loss percentages are the take profit and the stop loss, as we have set. Right now we have set them as equidistant, but then you can set it up as any way you want. And then as we go through this small df, which is a subset of our total sort of price data, we ask whether, so our buy list contains all the stock that we have already bought. And we look at the copy of the list because we don't want to change the same list that we're iterating on. That's an important nuance on Python. So if the high price is greater than the profit percentage, then we remove this from the buy list and we append this to the sell list. So we have been able to sell one of the Bitcoins at a profit based on the price. And now after that, we check the stop loss. So if our low of the candle is less than the stop loss, then again we sell, and in this case we sell at a loss. So we again append it to the sell list. So these are conditions in which we sell the Bitcoin. So these are exits of the trade. And now in order to do the entry, we generate a random number with the prop buy as the proportion of times the random number is going to be 1. Since we set this to 1, this random number is now always going to be 1. So if the random number is 1, and then we haven't exceeded the max buy, and the crossover is also 1. The crossover is what we calculated based on the fast and the slow moving averages. In that case, we enter a trade, which is by appending to the buy list here. And then we can look at the total profit. And as you can see in this case, we may have made a loss. And we can look at the individual trades we had in this particular example. And as you can see, we entered here where there was a crossover, we made a loss. We entered a second trade again when there was a crossover. Again, we made a loss in the second trade. And finally, in the third trade, we did manage to make a profit here. And that was the sort of single profit we made among those 3 trades. So that was the strategy. We basically wrapped everything into a function. We put all our arguments into all the variables of the function as the arguments here. So these are all the variables of the trade. And then we again execute the exact same thing. So what we did in this case was to sort of try to play around with the fast and the slow moving averages. And by doing that, we were able to generate a profit. But again, this is sort of one single random run. And it doesn't really say whether a different run on a different data set would produce a profit. So that was the Python code. Now let me explain 2 important points. One is that we observed from the code that by changing the fast and the slow moving averages is one of the keys to determining whether the strategy will win or lose. And this is something that you will have to sort of do a grid search in order to find the best or optimal value of the fast and the slow moving averages that allows you to generate a profit. The second condition is, of course, the stop and the take profit and the stop loss percentages, which again you have to sort of search through them. The second important point I want to make is where this strategy works and where it doesn't. The strategy doesn't work when you have a sideways trade. So you can see, like when the stock is trading sideways, there are a lot of sort of different points where there is an intersection between the fast and the slow moving averages, and you're just caught in one of those random sort of intersections and you end up losing. Where it does work is where there is a very strong upward trend, and even though it's a lagging indicator, you are able to sort of catch the tail end of the trend, like somewhere here. But if you look at the first 2 trades, it's sort of more random. The stock is trading sideways, and then the indicator is not that useful. So those are the 2 important points or 2 important pitfalls that I wanted to mention about the simple moving average indicator. Hope you enjoyed this video. Please like and subscribe if you like to see more such backtests using Python for trading strategies. Thank you.